Okay friends, in this video we are going to solve questions from Euclidean geometry exam questions. Okay, this is question 10 from DBE from paper 2 from 2020. Okay, this is the question 10. In the diagram you have a circle passing through D, B and E. Okay, D, B and E, and you have diameter ED. Okay, ED is a diameter of the circle which is produced to C. Okay, produced to C, and AC is a tangent to the circle at B. Okay, AC is a tangent to the circle at B. So B is the point of contact. You have M is a point on DE. Okay, M is a point on DE. Okay, such that AM is perpendicular to DE. Okay, AM is perpendicular to DE. Okay, perpendicular. And AM and chord BE intersect at F. Now, 10.1. Prove giving reasons that 10.1.1. Prove giving reasons that FBDM is a cyclic quadrilateral. 3 marks. Okay, FBDM. So we have 3 ways to prove that a quadrilateral is cyclic. We have 3 ways. The first one is to use the fact that you have an exterior angle is equal to the interior opposite angle. This is one way to prove that a quadrilateral is cyclic. Okay, so I can use the angle M2 and prove that the angle M2 is equal to the angle B2. So you have angle M2 is equal to 90 degrees. This is given. Okay, now you have angle B2. Angle B2 is subtended by the diameter. ED is a diameter. So this angle is equal to 90 degrees. An angle subtended by a diameter is equal to 90 degrees. Okay, so angle B2 is equal to 90 degrees as well. The reason you are going to say angle in a semicircle. So angle M2 is equal to angle B2 because of this. So therefore FBDM is a cyclic quad because converse exterior angle of cyclic quad. Okay, converse meaning the reverse. Okay, the reverse. We have used the angles to prove that a quadrilateral is cyclic. Okay, we are going to see about this in lesson 24 of 25. This is one way. Another way, 10.1.1, another way is to use the fact that the sum of interior opposite angles of a cyclic quad is equal to 180 degrees. Okay, this angle M1 plus angle B2, this is equal to 180 degrees for a cyclic quad. You have angle M1 is equal to 90 degrees. The reason is you have AM is perpendicular to DE. So angle M1 is equal to 90 degrees. And you have the angle B2 is equal to 90 degrees because this is an angle subtended by a diameter. So the reason is angle in a semicircle. So now can you see angle M1 plus angle B2. This is 180 degrees. So you can see the sum of interior opposite angles is equal to 180 degrees. Therefore, we can conclude FBDM is a cyclic quad. The reason you are going to say converse opposite angles of cyclic quads. Okay, let's move on. We still on question 10.1. Okay, 10.1. Now 10.1.2. Okay, we have to prove that angle B3 is equal to the angle F1. Okay, we have to prove that angle B3 is equal to the angle F1. Okay, so can you see angle B3 is between a tangent and the chord BE. So this angle is equal to the angle in the alternate segment. From the same chord, you have angle D2 on the circumference. Okay, so this angle is equal to this angle because of tangent chord theorem. Okay, so angle B3 is equal to the angle D2. The reason is tangent chord theorem. Okay, then chord theorem. You can also see angle F1 is an exterior angle of this cyclic quad. The exterior angle is equal to the interior opposite angle D2. Okay, so exterior angle of cyclic quad FBDM. Angle B3 is equal to the angle D2. Angle F1 is equal to the angle D2. Therefore, you have angle B3 is equal to the angle F1. Now, question 10.1.3. We have to prove that triangle CDB is similar to triangle CBE. Okay, let me erase. So triangle CDB. Okay, so we have to prove that the two triangles are similar. Okay, CDB, CDB, and the triangle CBE. We have to prove that the two triangles are similar. So we are going to work in triangle CDB and triangle CBE. So to prove that the two triangles are similar, we have to show that three angles in one triangle are equal to three angles in another triangle. So you have this angle, angle C, is common in both triangles. Okay, so angle C in this triangle is equal to the angle C in this triangle. Okay, the reason you are going to say common angle you can also see angle B1 is equal to the angle E, because you have tangent chord theorem. You have another angle in the alternate segments from the same chord. Okay, so angle B1 is equal to the angle E. The reason you are going to say tangent chord theorem. Okay, tan-chord theorem. Now, when you prove two angles in one triangle are equal to two angles in another triangle, automatically the third angle in one triangle is equal to the third angle in another triangle. Okay, so this angle in this triangle, okay, is equal to this angle in this triangle. Okay, so angle D1 is equal to the angle CBE, this angle, automatically. The reason, because of sum of angles in a triangle. Now you can conclude you have triangle CDB similar to triangle CBE using angle property. Okay, so let's move on. Now question 10.2. okay, 10.2, we are going to solve 10.2.1. we have to find BC. This is BC. Okay, BC. So from the previous question 10.1.3, you have this triangle is similar to this triangle. You have BC. Okay, you have BC. Can you see BC in the triangle? Okay, so since this triangle is similar to this triangle, we can write the proportionality equation, and from the proportionality equation we can solve for BC. So since this triangle is similar to this triangle, okay, the triangle CDB is similar to triangle CBE using the property angle. So let's write the proportionality equation. You are going to have CD over CB equal to CB over CE equal to DB over BE. Okay, let me show you how to write the proportionality equation. So you have the first and second letter in this triangle over the first and second letter in another triangle, okay, CD over CB equal to, now you are going to take the first and third letter in this triangle over the first and third letter in another triangle, okay, CB over CE, okay, equal to, now you are going to use the second and third letter in this triangle over the second and third letter in another triangle, okay, DB over BE. Okay, so this is how you can write the proportionality equation. You can write the proportionality equation when you have one triangle similar to another triangle. Okay, so the reason why you can write the proportionality equation is because you have similar triangles. Now from the equation we can find BC. BC or CB is the same. you have BC in this ratio and BC in this ratio. So we are going to use this part. Okay, we are going to use this part because you have BC in this ratio and you have BC in this ratio. So you need CD. You are given CD. You need CE. Can you see? CE. CE is made up of CD, okay, CD and DE, okay, CD and DE. You understand? CE is equal to CD plus DE, which is 2 plus 6. So CE is 8 units. Okay, so we can cross multiply BC times BC, which is BC squared, equal to CD times CE. When you cross multiply, this is equal to CD is 2 times CE. CE is 8. This is equal to 16. Now, BC squared is equal to 16. You need BC. BC is equal to square root of 16, which is 4. So, we have BC. Now, question 10.2.2. We need DB. We need DB. Okay, DB. Let me erase this. We need DB. We can use Pythagoras theorem because we have a right triangle. Okay, remember angle B2 is 90 degrees. The angle B2 is subtended by a diameter. Okay, DE is a diameter. You can see. Okay, so this is a right triangle. Okay, this is a right triangle. We can use Pythagoras to find DB. Okay, to find DB, we can use Pythagoras. So let's use Pythagoras. Okay, always remember the sides opposite the right angle is your hypotenuse. This is the hypotenuse. The hypotenuse is always opposite the right angle. So we are going to write down the Pythagoras theorem. The Pythagoras theorem says the hypotenuse squared is equal to the sum of the squares of the other two sides. Okay, DE squared is equal to the sum of the squares of the other two sides. So you have DB squared plus BE squared. Okay, now we can solve for DB. Okay, DB. We have DB. DB. We can solve for DB. So the reason for this, you are going to say Pythagoras theorem. Okay, so DB squared is equal to DE squared. You take this to the left, you have minus BE squared. So you have DE. Okay, you have DE. You need BE. Okay, you need BE. We don't have BE. Okay, we don't have BE. We can find BE using this equation because we have BE in the equation. So you have DB over BE is equal to, you can use this ratio or this ratio. Let's use this ratio. So this is equal to CD over CB. You are going to have 2 over 4. Okay, CB or BC is the same. So you're going to have 2 over 4, which is 1 over 2. So the reason for this, you have similar triangles. Now you're going to cross multiply. You have BE times 1, which is BE, equal to DB times 2, which is 2 DB. So DB squared is equal to DE squared minus, now BE, this is BE, okay, you have 2 DB, okay, BE is equal to this. You close, remember, squared. So you are going to have 5 DB squared, okay, you have 1 DB squared on the left. When you take this to the left, you are going to have plus, okay, plus 4 DB squared. Now you have 5 DB squared equal to DE squared. So you are going to divide by 5 on both sides. Now you have DB squared is equal to DE squared over 5. You are going to square root on both sides. So you have DB is equal to square root of this. You have DE over square root of 5. Now DB is equal to DE over square root of 5. So DB is equal to 6 over square root of 5 units. Okay, and we are done with this question. Okay.